Write the system of linear inequalities shown in the graph. So when I look at this graph, I have a solid red line right here that looks like it's being shaded to the right. I have a dashed blue line right here that looks like it's being shaded down. And I have a dashed green line that looks like it's being shaded up. So I have three different graphs going on, and I can see that they all three share the center triangle region. But what does this mean, and how can I use this information to help me write the system of linear inequalities for this graph? My teaching assistant Chloe is here with her latest cheat sheet notes. First up, she wants you to know that when you are graphing inequalities, go ahead and graph all the inequalities and shade them on the same coordinate plane. Where all the shading overlaps, that is the solution. If you have any solid lines, those are included in the solution. If you have dashed lines, those are not included in the solution. Now that we have Chloe's little cheat sheet notes here, let's go ahead and break this down. Now I know when you're looking at a graph, you cannot break it down individually, but to help you learn this, I'm going to show you each individual line and how it can help you to look at them separately. So the first one I'm going to look at is just that solid red line that we had. And you can see that that red line right there is going through the point -2 right here, and it is solid and shaded to the right. So the first thing I'm going to write here is a solid line and that it's shaded right. Now, when it is shaded right, we know it's going to be in x form. So it's going to be x greater than or greater than equal to, less than or less than or equal to. Since we are going to the right, we know that that's going to be x greater than, and because it's solid, it's going to be greater than or equal to. So our x-intercept was at -2, so we will write this as x greater than or equal to -2. So when I go back to showing you what this looks like on the graph, you can see that that was that solid vertical line right there that we did, and that was everything shaded to the right. Now let's go ahead and look at one of these other dash lines here. So this first dash line we'll look at, you can see that it goes through, well, with the dash lines, we'll write that, and it looks like it's being shaded above the line or going up the y-axis. So we shade it above. When you have a dashed line, it's going to either be greater than or equal to. And because we shaded above, that's our sign that's going to be y greater than. So we're going to have our y-intercept right here, which is at -4. And I can see that my slope in this problem is 2. We go up 2 to the right 1, up 2 to the right 1. So since we figured this is going to be y greater than, we can put that in our mx plus b, 2x minus 4. So now we have our next line here. And just to show you what that looks like back on the original problem, we just did this one right here. And you can see that we shaded everything above it. So for this one over here, x greater than or equal to -2, we shaded everything to the right of this vertical line. And for this dashed line here, we shaded everything above it. So just those two lines overlapping have just this little section right here, a part of each other, the same. And then this line is the next one we're going to do that even breaks it down into even a more specific section of just this triangle. So that other one we have is a dashed line. So let's look at that one individually. It's dashed line, and we are shading below the dashed line. So dashed line means it'll be greater than or less than. Shading below means it will be less than. So this will be a less than problem, y less than. And you can see I have my y-intercept here of 5. And then I can go ahead and figure my slope by just going down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. So my slope is -1. So to write that as an inequality, that's y less than -1x plus 5. And we can really drop that -1 in front and just make it a -x. So we have y less than -x plus 5. Again, when you are looking at this overall, you can now see all three sections. Now it can help you to draw arrows. So I know that this one, we were shading to the right. This line right here, we were shading below. And this line here, we were shading above. So this can help you by drawing the arrows to see Where do all three sections have some type of shading overlapping? And the answer to that one is anything that is in this triangle right here would qualify. So to write this system of linear inequalities, we can write them all just like this in one place.